this this year we'll start with GCP. And as the first thing, what I do is since we also have that other knowledge on other clouds, so I thought I will do a first like how we started in Azure. So I will do a comparison of the breadth. So that you understand what all the products are there, and also I will try to compare that equivalent to AWS and Azure, so that we get an idea of what is common, and since we know at least some of these people in this group are familiar with AWS and some of them are familiar in Azure. So you could create a picture in mind when you even though before we go into deep dive into the specifics of the product within GCP. So I thought of covering the breadth of what GCP is, and want to also compare parallelly with AWS and Azure, so that if we can frame a picture in mind, then we can go into specifics of each product, like how we went before. So it's the same process that we followed even in Azure. So yeah, so with that, yeah, so I want to just start with account, so which is very starting point for any cloud for that matter. But how this account hierarchy will look like in cloud, especially in GCP. So I'm just before going to the GCP specific, since you already know AWS, I think I'm just going to give you the intro of AWS equivalent, how this account will look like. In AWS, as you know, it's all AWS account, and there will be account owner, and this account owner generally will hold an AWS account, and there's no further splits here. After that, it's just resources. I mean, under AWS account, you'll have various AWS resources. So starting from EC2 or whatever. So the typical AWS resources. So there's not much hierarchy in AWS. But if you compare the same thing with Azure, in Azure we have account, and under that there is something called subscription, and under subscription we'll have the resources. So this is the Azure hierarchy. So in Azure also, I mean, in addition to that, the subscriptions can be further split into various categories, like account administrator, who will have like a super owner, will have access to everything. Service administrator, he can manage only specific resources but not billing. So billing will not come under service administrator. Co-admin will have complete control, but cannot change the service administrator. So it is like hierarchy, superpower, medium level, and even further down. So this is a further subcategorization under subscription. So that is how Azure is. Now, if you come back to Google, um, Google, this is similar to what is there in Azure, but slight modification. But there is a good hierarchy that is maintained in Google, where if you start, there will be something called organization node. Every company will have for example, GCP account is there for an enterprise. So the enterprise level, there will be their enterprise is called organization, and under that enterprise or company, there will be something called folders. So the folders it could be department, like a department X, department Y within that enterprise, um, and even that department could be further split into teams, and the teams could be further split into products. So these are all called folders. So under organization node, you will have folders, and under folders, you'll have projects. For example, product one, if you take, again, they have various environment. It need not be an environment, but logically, this environment is a logical choice under this. A test GCP project or production GCP project. You can have projects like this. And under this project is where you create the actual GCP resources like storage, VM, all those specific resources. So this is and this looks logical because this is how any organization is hierarchically divided, right? I mean, there will be always a company, and there will be a company with a lot of departments. Under that, there will be teams and products and projects, and under that resource, and each project will have few resources, and that makes sense because that is more logical to any organization. So that way, I like this hierarchy. even more logical in our real time, right? So in a real world organization. So on this side of this diagram, this is how the GCP console will look like. The screen is a bit blurry, but I think I will just read out. So my organization, which is this parent, this company, under that if you see engineering, which is a folder, and engineering will further have, which could be considered as a department. Engineering is a department. Under engineering department, you have product A and product B. So under product, again you have folders like development, production. So and under production, these are all folders, and under this folder we have projects. For example, this is my awesome service one. This is a project, and inside this project you'll have resources. So and yeah, so that is how it will look in GCP. So that way, when you're doing for a billing, it is you can do the billing per folder, uh, or you can do the billing across the organization or company. So yeah, so the key takeaway is it is exactly like your current company, where there will be organization, and organization will have folders, and then we'll have projects and the resources. Any questions? Okay. So with that, let's move further. Let's now look at how regions and zones will look like. Here in regions and zones, I think I didn't find any. A lot of similarities are there between. I don't see any difference. In all the three places, region is called as region only. So yeah, I mean in AWS we call region. In Azure it's called region, or also called as paired region. So you already know what is paired region in Azure. And GCP also is called as region. So these numbers that I put is all the count of the regions available in the respective cloud uh, from the cloud vendor. For example, AWS has 24 regions around the world. Similarly, Azure has 60, and yeah, GCP has 24. So more or less, AWS and GCP are going in line with going closer. Um, but if you look at Azure, is leading in the number of regions. So I mean they're widespread compared to other cloud vendors, at least on the region side. Um, and next is the availability zone. So like I mean how we organize this presentation is that maybe I should explain that. So on all the slides going forward, you'll see a comparison box like this. What I explained is here is a concept. What is that we're trying to compare, and then what is that concept, how is it called in AWS, Azure, and GCP. This is how I did a comparison on all the slides. But it actually it is this enlightened me in many ways in terms of how each cloud is comparing, and how they're more similar in most of the ways, and how they're different. So that perspective is a good perspective to get. I think this took some time to collect this list, but I think it is very useful. Um, yeah, just coming back to yeah. That's how if you look at this region. Yeah, the cluster of data centers and services which are spread across. So that is what is the region. And the data center, so abstract data center is called as availability zone. So we know what is availability zone is. So it is abstracted data center. And if you look at the counts, AWS is 77, which is very huge number. And availability zone here it is reduced to 16. And whereas in GCP is called as zone. So I mean, just to be unique, I think there are some names which are common, but some names which are different. So here it is called as zone, not as availability zone. Yeah, one thing which is very interesting to note is that even though the regions are high in Azure, but the counts of the availability zones are less. So which means that you should be very specific when you're looking for higher reliability. For example, the availability zones will help you for for more uh, data reliability aspect, right? So you can take the backup to multiple locations you can keep a backup so that even if the disaster happens in one availability zone, the other availability zone will still be there. So that is the power of this availability zone, where you can keep a redundancy aspect can be taken care by duplicating the copy of your data into another zone, so that you are minimizing the risk. In that way, the availability zones as such is lesser in Azure compared to equivalents of AWS and GCP. So, but just a note. But the region size they're widespread. And the next layer is edge caching. Edge caching is not a real data center, but they're like CDN content delivery network, where they're closer to a caching layer which is closer to a data center. So whenever a location, whenever a person is trying to access a particular AWS or Azure resources, if they are not available in the availability zone or nearer to the availability zone, so generally the traffic will go to the nearest edge cache. So edge cache will be generally, there will be counts will be very big, because it's not a full-fledged data center. It is just a caching mini data center. So they are all called as POPs. So that's how this cloud, all three terminologies in all the three places they're called as POPs. So edge caching layer, if you look at the counts, if you look at AWS is having 220, Azure is 130, and GCP is 144. So if you just compare it up, what I see is that AWS and GCP are going neck to neck in more or less, except the counts are not big, but and they are also very hugely expanding now. So there, if you look at this availability zone is what is important to me, because this will compare to regions which are widespread. Availability zones are more. I mean, there was a talk which I was reading, how to what is important for any organization from cloud perspective. Is it availability zones or it is regions? I mean, the answer, it depends, but it is region is good. I think it will give a widespread availability of a service. But imagine there's a service which is there in a region, but there's no availability zone. But if you're looking for availability zone that is not there, then you are left with using just that data center, only one data center in that zone, one data center in that region. You don't have a second or third data center is not available. So yeah, that is something that we should keep in mind when you're opting for which cloud to go for. So this availability zone is equally important, and especially depends on where your customer or where your traffic will come from. If it is Asia based or Europe based or US based or whatever. So it depends on which you need to decide on what is your location of your users and how many hits you get, and for that, are there availability zones in that region for the given cloud vendor? That is something we should keep in mind before we make a decision on opting this services as well. So yeah, but yeah, again, the stars are just as of today, but these counts are changing every day. So yeah, this can change every day. So yeah, but as of now, this is the status. Any questions here? Right. Okay, let's move on. Then next is the compute. This is where I start. And this compute is logically organized into infrastructure as a service, platform as a service. Just a variation to it, containers and orchestrations also come under compute. So this is also important compute, which you talk about. Kubernetes will come under this space. Yeah, I think that's how it is organized in the slides. So if you look at coming to the virtual machine, the compute primarily on the virtual machine, which is infrastructure as a service category. I mean, yeah, we know that virtual machines in AWS is called as EC2, in Azure it's called as Azure Virtual Machines, and in GCP it's called as Compute Engine. So I mean, I highlighted this because just if you're looking on GCP side, so I just want to just get this board, but nothing else. So this virtual machines is in GCP side it's called as Compute Engine. So whenever they say Compute Engine, they are referring to the virtual machine there. And for large scale parallel computing, I mean, this is all suitable for a normal requirements, but if you're looking for a parallel computing and large-scale computing, something called batch, and it's all named same in all the three environments: AWS batch, Azure batch, GCP batch. Um, so it generally helps you to give the parallel computing aspect. And next is the scaling, VM scaling. As you know, one virtual machine you created, but you want to replicate it. We want to auto scale, scale up, scale down based on the demand. So if that is the case, then the terminology is in AWS is called auto scaling, and Azure it is called the virtual machine scale sets (VMSS), and in GCP it is called as managed instance groups. So with managed instance groups, you can logically group the resources. That's why it's called instance groups. And then you can group it, and you can set a threshold based on threshold. When there is a high demand, automatically the machine should be scaled up. Once the demand is normal, you come back to the normal. It will scale down to normal count. So that's about the medium scaling aspect. I mean, from this, just be familiarized with the terminologies. I think we'll go in deep in each of these when you complete this breadth aspect. We'll go in specific deep into each of this. And coming to the VMware based services. So I mean, VMware is what I mean. There's already most of the enterprises they're already using VMware. They already have a lot of infrastructure on VMware. Now that most of the data centers before cloud era is all completely took over by Dell and VMware. Right? So that's why good thing is VMware had a good tie-up with all the all the cloud vendors, and so they have VMware-based services in all the clouds. That's what it's called. I mean, the equivalent names are VMware Cloud on AWS, VMware by Cloud Simple. Cloud Simple is another company which was acquired by Azure. So that's why it's VMware by Cloud Simple. It's not a direct product from Azure, but it's an acquired product. And VMware as a service in GCP. So the advantage in this product is that because you as a data center as an enterprise you already have invested on VMware for a data center, and that's why you decided to move to cloud. So you can you can reuse your existing VMware licenses on cloud. So you don't need to pay anything extra. So all your hardwares or infra that you had already invested. So you can, of course, you can't. Um, the licenses can be reused, but of course the hardware that can't be done, that can't be moved to cloud. But at least your existing licenses that you would have had, let's say you had a contract with VMware for 3 years or 5 years, so that contract can be moved to cloud, and that can be placed in the cloud when they're using that. The licenses can be reused on the cloud. Right. So that's about
Yeah,
the.
this service is very useful for the migration strategy. This is one of the easiest migration strategy. Each cloud each cloud vendor provides their own migration way, so you don't even have to use the VM. The existing one could be converted into the EC2 or the respective way. But if you maintain this way, you could swap between the AWS to Azure to the GCP because you have a wrapper layer on the infrastructure itself. So you're not still tied. If you just migrate to AWS, then migrating from AWS to Azure is a little bit trickier. It nowadays nothing is trickier. Nowadays, the way the cloud people are doing is they lucrate you to, if you come now, I'll give you everything, give you the migration. Usually they charge for the migration initially, but nowadays most of the migration things are all the tools are all free except the consulting hours. That's where it is. But this VMware, I don't know how far they are going to stick to the. I think this might be one of the option to move the existing VMware easily to the cloud. And if they feel comfortable with the cloud, they don't need to have the VMware. They don't have to pay the license after 5 years. So that is a big question mark for them. They have to. I don't know the validity, right, Vishal? Do we really need that or not? The layer itself.
No, I think the VMware is it is not just I mean, the investment on the hardware. It is also the people who 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 the company all the engineers who would have worked on VMware so far now. So they have to be trained on the cloud also, right? So the advantage with this VMware services in the respective clouds, so they no need to know something new in cloud. So the knowledge that they gained on this on-premise VMwares, they will be the same on cloud. So they could easily manage. They can use the same VMware suite of tools on cloud, but just that the infrastructure, underlying infrastructure, will not be on a physical hardware, but it will be on cloud hardware. So,
Yes.
but the VMware tooling will remain the same.
So Sham,
Yeah.
Raj here. A question. I have not been actively practicing with VMware, so this is a basic question in terms of in the days of data centers, on-premises data centers, when companies running their own data centers, VMware made a huge impact of utilizing the hardware, using the machine that they have to create multiple virtual machines and run their own OS and applications, thereby reducing the investment cost. Now, also to administer easily. But in the days of the cloud, in any of the three major platforms, is it still relevant? Is VMware, do you see from the practical point of it, if I am a company which is running multiple applications and then I have a huge system partitioned and managed by VMware, and when I migrate those, let us say it has some 20 different virtual machines, and when I move to AWS, for an example, I don't need to carry the baggage of VMware and then installing it in a virtual machine in the cloud. I can directly move each one of the VMs as a small systems in the AWS. So where does the relevance of VMware stands today with the cloud architecture?
Yeah. To answer that, I think I mean, the VMware, if you know, there are a lot of tools inside VMware, right? It comes as a big tool set. It comes with a lot of tool sets, like vSphere and all those products under the VMware category. I'm not an expert in that area, uh, so the idea is the I mean, one of the main pitching point. I attended one session on this AWS side of VMware Cloud on AWS. So where that what they're talking about is uh, VMware comes with a lot of infrastructure management software that comes along with, and people over a period of time they gain a lot of experience on this vSphere equivalent tools from VMware. Uh, so so you, so what I understand is the tooling will remain the same. So they don't need to know something new in the cloud world, but the underlying hardware that they're managing will be VMware based hardware on cloud. So basically, the cloud vendors have an option to, I mean, when they buy the hardware in data centers in cloud, I'm talking about the AWS or Azure, when they procure, they VMware is one vendor from which they can purchase the hardware, but also they can purchase hardwares from like other providers also, who could be competitors to VMware. Um, but as enterprise, when you are moving to cloud and you are a VMware house, uh, then uh, then AWS or any other cloud vendors, they're if you're using this VMware cloud of service, then your underlying hardware will be completely only VMware, not any other underlying hardwares. But the hardwares will not be in your control; it will be in the data centers of these cloud providers. But the tooling that you have, that you gain knowledge, you can reuse it but just the hardware will not be on your data center, it will be on cloud data centers.
Okay.
So it's basically the relevance is more on the hybrid. That is where the world is. At least the mid-sized company upwards, they all have the data center invested already, and the cloud is not going to replace the existing data center. But even though they say that way, but there is a prediction in next 1 year. By next 1 year itself, there is going to be a consolidation of hardware by 30 to 40% into the cloud, mostly AWS and Azure. So yeah, so if you still want to keep your employees happy with their skill set, yes. But nowadays, companies also think they want to have the employees who could span the technology. They could learn across, so that they get the benefit. See, if you go to the specific tool of cloud, for example, you get a lot of cost benefit also. Whenever you have a wrapper, it's like paying for the middleman. You pay for the middleman because you get the interface what you already kind of know. So that and one more thing, what I have seen very compelling is you could, with one dashboard, you could control both the cloud as well as the on-premise things at one shot. So it gives lots of operational benefits. I think that is where the benefit of the VMware, so that when you tie to your cloud, you're tied to the cloud. But when you are in this kind of a layer, you still have the same interface and same kind of mechanisms, and also looking at the log files, looking out what gets spawned between. But Kubernetes also comes in that picture later. We will talk, but so the VMware relevant is slowly going to be diminished unless they come out with something else on top. That's what my.
So Srinya, I see this as VMware is the hypervisor, which is commercial hypervisor, right? There are other hypervisors, which is called hypervisor is the layer that sits between the hardware and your OS. So hypervisor is the one which makes it look like you have multiple machines with just one hardware.
Yeah.
So VMware has been in the industry for a long time, and it is like it has become the status quo, or like what do you call de facto standard in hypervisors, right? So irrespective of what the hardware is, VMware can manage it. They have something called ESX or something like that, right? So that hypervisor is like commercially supported, and all the data centers that they have. So I see this as like kind of a liberty to move. They're basically introducing a standard and moving from one cloud-based vendor to the other cloud-based vendor, provided they support VMware, right? So that's means of course you have to pay VMware their share of their revenue, right? Like
Yeah.
so that is there, but
Yeah.
what I'm seeing it is like it's a kind of a standardization of the cloud-based vendors, and for the company the benefit is like there is no tie into one particular cloud vendor. So as long as your VMs are like your computes are going to be VMware compatible, you can say like AWS is too expensive, I can move to Google now. So it's just that flexibility is there. But I don't, just moving the VMware VM alone is not enough, right? Like there is underlying architecture that went along with AWS. So that's where I don't see that is coming along well, right? Like so maybe configuring the VM is much easier. I think that's what that might be the it's like detail that is playing along. But I think what I feel is like the standardization of the hypervisor, the compute solutions across the thing, right, will give you like independence. Like you don't get tied into one particular vendor.
Yeah, that's true.
Yeah, if they open source it, I think I like it.
Yeah, the challenge is instead of you get out of some of these multiple things, but you get yourself logged into VMware if you have to go that way. Yeah, there is pros and cons in both, but I understand from all of your point. Yes, there is a value in continuing to use it. Yeah, I think only time will tell as I hear from you guys.
Yeah, that's true.
Yeah.
Yeah, I mean that is the if you see the from this itself, it's there in all the three cloud vendors. So it shows the popularity of VMware in enterprise, and uh, and just to all this the VMware came into cloud in the last 2 years. And started with AWS, and after that VMware was introduced in Azure, and then now in GCP also. So unless I mean, this is a good point for forcing the enterprises to move to cloud. Once you need to know something new, you can rely on your existing hardware. You need to learn something new, you can rely on your existing tooling. But it's just that infra alone will be on cloud. So yeah, so that way it is a win-win for enterprise to the enterprise employees not knowing something new. They can rely on the existing ones, and maybe slowly once they come to cloud, once they see the taste of the cloud, then they move probably to others. So once they see the drawbacks where VMware couldn't integrate with other products of the cloud, then eventually they'll be forced to migrate to other infrastructures of the cloud. So cloud is just one way to for enterprise to come to cloud. Okay, so let's move on. So next is the high performance computing. So all these things which all this stuff which came in the last 1 or 2 years is very new. So all this parallel cluster is what is in AWS, Cycle Cloud, and the high performance computing. So this is all for heavy workloads where you are looking for a bigger compute and also a distributed compute. That's why it's called cluster. So, so if you're looking for a heavy compute requirements, then where your normal virtual machines will not suit, then this layer will help you. So that's where they have all this come under infrastructure as a service. So it's all infra is what is provided by this services. Um, yeah, so that's about infrastructure as a service on the compute side. If you move to platform as a service, I mean, most of them, this concept is managed hosting. So you have a jar or you have a binary of .NET or any other library, but you just have the code, but you don't want to manage the infrastructure, the scaling, and also the cluster increase, decrease, and all those. You don't want to manage that, but you just want to simply you want to just manage your code, and you're looking for a managed solution. Then the answer is this, like just in AWS we have Elastic Beanstalk, and Azure we have App Service, and then GCP it is called AppNG. So all these vendors, they provide a runtime for various technologies like Java runtime, Python runtime, .NET runtime, so Ruby runtime, Go runtime. So they provide all the runtimes. So you don't have to worry about anything. If you just have your library, if you have Python library or if you have a Java library, you can dump your jar or container into this respective products, and they'll be deployed. So you don't have to worry about the scaling part. Everything will be managed by the cloud. You just deploy your code. That's all. That is what you take care. The stuff it will be managed by the infrastructure management will be completely managed by the cloud vendors in this case. So that is what is this platform as a service. Right. I mean, here you will not have control in managing it. It's all completely managed by the cloud. But if you don't want to manage that, that is not your primary headache. Then this is a good choice for you. So that's about on the compute side. We move to the container world, right? I think that's how all these things evolved. Like initially start with the VM and managed VM, and slowly evolve is moved to containers. The containers, and followed by containers, there came the container orchestrators, because it is good to manage one or two containers, but when the containers that we're talking is growing for every application, then suddenly it becomes difficult to manage these containers, because you have to manage so many containers. That's where this container orchestrators, which is like Kubernetes, will help you there. So under that space, again, they also come under compute category. But here we have a categorization of a serverless versus a non-serverless category. So first let's start with serverless. So for serverless category of containerized application, the answer in all the cloud vendors are like Elastic Container Services in AWS. Of course, this is not a serverless feature, but it became serverless feature is shortly. So again on the Azure, it is container instances, and in GCP it is called Cloud Run. So and one thing which is unique in most of products which I see is that everything in GCP starts with cloud run, cloud functions, like this starts cloud mostly, except most of the few products do not have cloud, but I don't know why, but consistently maintained. But at least 70% of the GCP products will start with cloud. So yeah, the Cloud Run, which is a serverless solution for containerized workloads in GCP. So, and I mean the idea is you're looking for your binary or your library, so that dotted Python, whatever. So you want to deploy that to cloud, but it is not as a jar. It's all container. So you have a container that you want to deploy, a Java container that you want to deploy in GCP. Then and let's say if it is also serverless. I mean serverless plus server together is cloud run. I mean, we can do both. But the answer for deploying a container-based workloads into cloud, but if you don't want to use Kubernetes, so then the answer is Cloud Run. And container, of course, all these containers should be stored in some place. Repository should be there because that's how you can orchestrate. Containers should be all co-located in one place, which is a repository. So the containers, it's all container image repository. So that repository is called as ECR, which is Elastic Container Registry in AWS, and in Azure is Container Registry, and it's called Artifact Registry here. And of course, the Kubernetes, the managed Kubernetes is called as EKS, Elastic Kubernetes Service. Here it is Azure Kubernetes Service. Here it is Kubernetes Engine or Google Kubernetes Engine. So GK. GK is more popular. I mean, I know in calling people Kubernetes Engine. Everywhere they call it GK. Yeah, GK has become standard in the and that's where Google is unique in that place where their Kubernetes they started this product. Right? They are the one who open sourced this product. And yeah, I mean, to give you the background, they had a Borg, which is the equivalent of Kubernetes. That's when last 10 years, Google is all working on Borg, URG Borg, and that the lessons from the Borg are how to manage the Kubernetes, how to manage these containers. All the lessons learned from Borg were all released as an open source solution which is called Kubernetes. And they made open source it and done given to Kubernetes Cloud Computing Foundation. So that Kubernetes open source project is donated to Kubernetes the Cloud Computing Foundation, and that's when CNCF, and that's when all this other. I mean, it's become so popular, and everyone migrating to Kubernetes. And suddenly managing this Kubernetes is it's not easy. So there is managed Kubernetes thing came, and all the cloud vendors also released their equivalents to managed Kubernetes solutions in the rest of the clouds. But yeah, the background is that GCP would be definitely ahead in this game because they are the one who developed this. They only brought this Kubernetes into market. But yeah, but now it is not just a Google solution. It is now open source, and everyone is contributing to the Kubernetes engine, Kubernetes software. But just that Google might have an upper hand because of their lessons learned from the past 10 years, which is the older version of Kubernetes, which is called Borg. Yeah, so just coming back. So once you manage this Kubernetes, so okay, now we have container. If you don't want Kubernetes, then you can go to Cloud Run or equivalents to that. And then if let's say you want to have Kubernetes to manage your containers, and Kubernetes equivalents are there. But yeah, then next comes service mesh. Service mesh is a further evolve from this microservices architectures, which has become so popular now. Of course, every microservice, I mean, for a flow to complete, for business flow to complete, end-to-end, for example, take the shopping cart example, there will be so many microservices just to hit a shopping cart, right? Once you once you check out a shop from shopping cart, there will be one microservice which will be sending instructions to the delivery team. There will be another microservice which will be reducing to the building part. There will be another microservice which will be doing the checking the inventory and managing the inventory. So there will be, just in a shopping cart example, there will be so many microservices that could be there. And suddenly this microservices, managing these microservices becomes so complex. That's where to manage that microservices, all the common problems that are there in microservices are addressed with the concept called service mesh, which will help you to manage your microservices better, because all these microservices will have common problems like tracing, logging, debugging. So all these things will be tougher. It's not like monolithic where everything is in one place. So microservices will be running in different containers and different distributed locations. So the logs will not be in one place. So managing all those microservices will be tougher. Um, so yeah, just to manage that, the evolve from microservices learning is service mesh. This service mesh, what it does is it organizes all your microservices, and it gives a complete visibility on the logging, all the common problems like logging and tracing. All those things are all addressed in this service mesh. Yeah, so the answer to that, service mesh as a concept, the solution in various cloud vendors are in AWS it is App Mesh, here in Azure it is Service Fabric Mesh, and in GCP it is Anthos Service Mesh. So yeah, this Anthos is a you see this Anthos in multiple places, but this Anthos is in GCP is again a multiple tools kept into one bucket kind of a category. So in Anthos we see Anthos like service mesh is one, but there are other products which come under Anthos. I think we'll see in the following slides. But I just want to give that Anthos is a group of tools put together. Um, right. Yeah. So that's about this container orchestrators. Summary. One, if you're not interested in Kubernetes, Cloud Run or equivalents. If you're looking for managing your images of container images, repository, then artifact registry, equivalents, Kubernetes engine, equivalents, managing your services, microservices, then service mesh, then yeah, equivalents. It's coming to the serverless world. This is again it is all event-driven serverless functions. So which has become so popular. Probably they are all event-driven serverless functions which will help you to respond to various cloud events. So these are all small computes where on the moment it will be spawn and execute the functionality and then dismantle automatically. So that way you don't need to pay for the entire compute. So for example, in VM, the VM is running for the whole year or whole day. So for which you are using or not, you are paying for the VM compute. But in the serverless world, it is on-the-fly compute. So when you have to execute something, you will on the moment create a CPU or a compute for your requirement, execute that job, and then complete dismantle your compute. So that way you're saving a lot on the you're not spending or you're not paying for when you really don't need a compute. Whereas in the VM you're paying for the compute whether you use it or not. So that is one area where the cloud spend can be reduced with serverless, but it comes with its own problems where all the architectures may not suit the serverless concepts, but wherever event-driven implementations are there or use cases are there, based on some event you want to take some action. So such kind of use cases, this would be perfect fit. So yeah. So for such, and that is in the microservices world, this is which is our industry is going towards. That's where this will more fit because most of the microservices are event driven these days. So yeah, but you should be very cautious because serverless is not an answer for all the problems. So it is the cost advantage, but it may not be a solution for all the use cases. Yeah. So then the answer for that in various cloud vendors are Lambda, functions in Azure, and in GCP it's called GCP Cloud Functions. So yeah, that's about this compute category. Any questions? Okay, let's move on. Next, come to the database. Database. Yeah, this. If you look at the database, logically speaking, we have relational databases and the NoSQL ones. Right, of course, there's a minor variant which is caching category. But overall, this is the three hierarchies, like relational database, NoSQL, and very different concept, which is caching. So under this relational database category, so in AWS, it's RDS. RDS is where we can have an integration to all the popular databases, starting from Aurora, which is AWS solution, and Postgres, which is an open source, MySQL open source, MariaDB open source, Oracle and SQL Server enterprises have approved entries. So all these things can be used. All these relational databases can be connected with RDS. And Azure, it is it's not just one product like RDS here, but here they're split to specific database. SQL database, which is their own proprietary Microsoft product, SQL Server, and database for MySQL, database for Postgres. So this is what is they separated their products for each database, like in RDS, AWS is just one. And Google follows the same, like AWS. RDS here it is Cloud SQL. So in Cloud SQL, it may not support all these databases that's here, but it is a popular one: SQL Server, MySQL, Postgres. These three are now supported as of now. But I think mostly others will join soon. But just what it is. Then these are all common databases, but which is looking for a horizontally scalable relational DBs. So I mean all these MySQL, Postgres, or others, there will be some limitations in because these are all not owned. Softwares are not owned by the cloud vendors. I mean, MySQL, Postgres these are all public. I mean, these are all community-driven projects, and the source code is not completely owned by the cloud vendors. So they will have some limitations in terms of the horizontal scaling. But if your requirement is you want a highly scalable DB, so then you should always go. I mean, you should go to the proprietary versions of the respective cloud vendors. All these cloud vendors they have their own proprietary DB, which they all the greatest and latest features that you're looking for, everything is embedded in that. So that is what is Aurora that we saw here in AWS, Cosmos DB, which is in Azure, and in GCP is Cloud Spanner. So the Cloud Spanner is for a smaller requirements for MySQL, Postgres, and all, you can use Cloud SQL. But if you're looking for a database which is spread across multiple regions, highly available and horizontally scalable, all these enterprise grade requirements that you're looking for, then this may not be a suitable option. So Cloud Spanner is the option. But again, this is if you're going with this, then you are going to the, the, the GCP specific DB. Here also the same thing in Azure specific and AWS specific. But that's how they pull you in to use their products. Yeah. So in in exam mostly there are some tricks around around the databases. So they given a scenario, you should select Cloud Spanner if you look the question is more on horizontal, scalable, all the popular I mean multi-regional location and 6 copies of replicas, all those things. Then answer should be the proprietary DBs. Yeah. Then that's on the relation side, and NoSQL equivalents. NoSQL, if you look, if everything is NoSQL, there are a lot of subcategories inside the NoSQL. Like the document store is a specific document. I mean, every row that you talk in a typical RDBMS is called as document. So it's a lot of variants there. Document store. If it is if you're talking about Facebook kind of where a hierarchical relationship is there, like A knows B, B knows C, so C, so obviously C knows B. So if you want to make a hierarchical relationship, so like which would be popular use cases could be a social media graphs, then GraphDB would be a suitable candidate, and other categories like key value store and a white column store. So these are the various categories under NoSQL, and we have options in cloud for specific use cases under NoSQL. For example, in the AWS, if you see, DynamoDB is a key value store DB and a document store. It supports both. That's what is DynamoDB. And SimpleDB, which is a key value store only DB. It's AWS SimpleDB. And DocumentDB is document store. So yeah, they have some variations here under NoSQL. In Azure, they took a different strategy where they prepared, if you remember, all-in-one, right? In school days, we have so all in one kind of a category. So they prepared, I mean, they developed something called Cosmos DB, which is their proprietary. But the advantage is that this Cosmos DB is an all-in-one DB where it can store all the options that you have in NoSQL. Everything is possible to use under Cosmos DB. Like you can store a document based NoSQL, graph based, key value based, and white column based. All these things it's possible to store in Cosmos DB. Yeah. Whereas in GCP, they follow the
But in Cosmos DB, you put it also under the relational. Is that relational also?
Yeah, it's also relational. Yeah. So it supports relational also, and also here non-relational. I mean both. I mean it has supports for both.
Okay.
So the Cosmos DB, the relational aspect is SQL Server, meaning the SQL database that you're looking at is the Cosmos DB relational structure. Meaning, just to give more background there, I think the Cosmos DB, the architecture, how they designed this is they brought all the engines, I mean the NoSQL engines and the popular SQL Server engine on the relational database category. So and they developed wrappers on top, so that way you don't need to know something new. You can rely on your existing knowledge of SQL Server, or for example, NoSQL like document store DB or key value store DB, whatever knowledge that you gained on this. So the wrapper that they wrote is in such a way that based on what library you select in Cosmos DB, you need to select a library first, which library you want to use. Based on a library, so they are converting to the respective DB engine behind the scenes, and they're executing the query and giving you the results back. So it's like
usually the NoSQL is cheaper than the relational thing. But I think Cosmos DB they charge in the standard way across, I suppose.
Yeah. That is, I mean, you have to pay. You're paying for the high availability aspect. So that high availability comes with a cost. So definitely, if you for a small POC kind of requirement, definitely it's a very costlier solution because it may not be needing the highly availability or multi-region deployments, copy replicas, all the things you don't need to have. No need for a POC.
Not just that. Not just that. If you use the PostgreSQL in Amazon compared to DynamoDB is much cheaper.
Yeah, that's true.
But here it's only one product, right? So you're paying for the irrespective of the usage, you're paying for that product.
Yeah, I think that is there. So, but I think I mean, if you're not looking for Cosmos DB, then you can very well go between these three. I mean, this is a relation category, but in the non-relation, there's no other choice. You have to go with this one. I mean, of course, I heard in Azure now they're introducing MongoDB, which is a recent release. The MongoDB, which is very popular in open source, which they're now integrating into Azure. So yeah, I think now they're also expanding, and they realized that Cosmos DB is their own proprietary. They're logged in, so they have to give the flavor of like how they give a flavor of open source like MySQL or Postgres. They have to give a open source flavor into the NoSQL category also, so that way they can pull in the people who don't want to get into who want to get logged in into the cloud specific DB. But yeah, this DB space is I mean, I definitely see AWS is a winner in this because they have all the popular DBs are all connected here. If you look at they're I mean, close around 7+ DBs are there in this. It's already 6, and also they also bring I think they already brought this Mongo DB also into AWS. And also they brought Elastic DB under the caching layer. So I think AWS is a clear winner in this database area compared to other cloud vendors. I think others will catch up soon. Yeah. Okay, looking at the GCP side for the NoSQL, everything is Bigtable. Bigtable is their solution for for all the NoSQL requirements. This will suit all but the only thing is it is a wide column store DB. But if you're looking for a document store category of NoSQL, then Firestore is the solution. Firestore, Cloud Firestore. Again, Firestore is also an acquired product from GCP. So, but this is more suitable for document store kind of a requirement, and also they are promoting Firebase real-time database. This is having I mean, feature-wise it is more real. The keyword is real time, so you can the latency is so less that is you can store the records very fast in this DB, and which will be suitable for high load application requirements. So Firebase DB is like it's a real time data store. That's what they claim here. So, but yeah,
so the wide column store definition is the number of columns it supports a lot.
It's a columnar DB. So you have it will have it's a column based, not row based. I mean,
okay, it's a columnar DB. Yeah.
Columnar DB. Yeah. So you can store many columns. You can just a relation DB reverse it, right? So you can store multiple columns in a columnar DB, multiple columns in a column, not rows. The column is more priority rather than a row. So yeah, that's just thinking reverse from relational aspect. Yeah. So yeah, I think more DBs are coming to this space, but I think this is as of today. But I see as I already know, MongoDB is already coming into this space under this. But yeah, more to follow for sure. And yeah, this is a separate variation here, which is a caching category. It's not a full-fledged database like NoSQL or a relational DBs. but these are more data before to a popular DB. You have it. If you, let's say you want to do a caching, so then this will help. The advantage of caching is that if, let's say you're more write intensive database, but you do writes more frequently. At the same time, you do a lot of reads. But let's say reads are more compared to writes. Then and the data will not change much. For example, then having a caching layer before your DB will help. So that way, when you do a read, like caching will give the results before even the query is going to the DB. So the caching layer will be before your DB, so that way the retrieval of the data will be faster, because all the data that is getting stored in a DB will be cached first. So that way, when a new request comes for a read, the caching layer will give the response rather than your request going to the physical DB. So I mean, the physical DB will take time to read the data. The caching DBs will be faster. So that way, the reads will be faster. More an architectural decision that the reads are more than caching will help you to retrieve the data faster. So in that category of caching database, the answers are Elastic Cache in AWS, and Redis, which is a popular open source and enterprise. Both are there in this Redis, but Redis is mostly used under the caching layer. So that's why both even GCP is also having a Redis equivalent. The cache for Redis in Azure, and Redis Enterprise Cloud is what is in GCP. And of course, there's a variation called Cloud Memory Store. This is again, if you want to store everything in memory, so in-memory kind of a DB is what is Cloud Memory Store. It's not an in-memory like SAP HANA, but it's a miniature version of a memory store where everything is similar to Redis. Redis will also store everything in cache, in-memory cache. So, but let's say if you don't want to go to Redis, or it will be definitely higher cost. So they give a lower cost solution. This memory store, cloud memory store is the GCP's in-house solution. But Redis is a third-party company having to maintain who develops Redis and maintains Redis. So yeah, if any organizations are already using Redis, then they can use Redis Enterprise Cloud in GCP. Yeah, that's about the caching layer. And this it's not comes under the database, but yeah, it's more similar. I mean, the tools which will help you for migration of databases to the cloud. So in that category, the primary database migration service. So you're already having an on-premise DB and you want to migrate to cloud. So all these toolings are very important from cloud, because only then they could convince the enterprises to move their data to cloud. So in that category, AWS solutions, I mean, all the names are same. Database migration service. They have solutions for all the three clouds. This migration service will primarily help you to migrate your data from your on-premise, let's say MySQL or a Postgres, and these tools will help you to migrate the data faster to the equivalents in the cloud. And they're also not like apple to apple. You can even they have tools which will give like apple to orange conversion also. For example, database migration services will also have tools which will convert the data from relational database to non-relational database. Like that's what I mean by like apple to orange. So even they do the conversion of that also. So yeah, and these tools are expanding because this database migration is one of the important piece in the cloud migration journey. So yeah, these tools I mean, migrating the DB from on-premise to cloud is and over the network is not an easy task. So all these tools will help you to migrate and also verify your data, and also do this more faster. Like generally, all this bigger enterprise will have petabytes of data on the DBs. So migrating that will take some time. Yeah, these tools will help you to reduce that reduce the time to migrate the data to cloud. That's where this migration services will help you. But any questions here? Okay, I mean, is it I mean, if you think it is, I mean, you can break it. It's, we can talk on something else, but if you have any questions, you can also.
Yeah, so I thought of, so even though we are going to have this at least an hour of a GCP content going forward, I would welcome Kasi and the people to start showing the Azure side also every week basis. So that way, like whatever they started their data migration or around that, right? Data fabric migration, right? So if you guys can continue that, take it to the next level weekly basis, at least 10 minutes. So that way, as a group, we also will be in touch with Azure and we'll have a discussion point and comparison across and so on. So just a suggestion, think about it. Okay.
Yeah.
So how is your preparation going on that arena? Is it going fine?
For the data factory, just I am jumping deeply now. That's
Okay.
if multiple files, if you're on from on-premises to Azure SQL or some other things, and how we can manipulate the data, that I'm trying to do now. Actually. So if I'm able to succeed on this week, so the next week I can show a small demo that.
Yeah. So that way you guys have something tangible and that is going to give you a motivation, right? It's always showing is what it's not easy, right? So
Yeah.
once you one suggestion is you take one use case and keep the same use case across all the features. So that way you give the functional context. Okay, I'm moving this file to here because of this reason, and I'm using this now. This tool is helping me. On the same use case, I'm adding this feature on top, and how this tool helps. So just to build a story around.
Okay.
So that when we record the session, we will record your session separately, so that as a playlist you guys can showcase that.
Okay.
That will help for job searching, frankly speaking. You have to stand out in the crowd, right? So those are some of the small techniques you can try.
Yeah. Yeah.
Yeah. So probably let's even continue further. So, but if you have any other points, we can discuss as well. But if you don't have that, we can continue further. Okay. Yeah. Let's move on. So it's messaging, which is very popular solution where generally for the messaging plays a major role where two services, microservices are two services. So now they want to asynchronously communicate the data between them. So generally there will be always on the messaging side there will be two people who is sender on one side and the receiver on the other side. So and there's a pipe in between. So this is just like a WhatsApp, right? So it's like person A is sending a message in WhatsApp, uh, and he's continuing with his work. And on the other side, the other person will check the WhatsApp whenever he is free. So and he will respond. So this simple concept. So for that kind of a category, you need a layer called like whatever is the WhatsApp that you're talking about. There should be some server with some the messaging layer which will store the data temporarily into the DB, and also it can store the data, and then also whenever a subscriber on the other side, whenever he is seeing, it will show the data to that person, and whenever he is sending, he will show the data to this guy. So it is like equivalent for a mediator in between two people, two services. So that's where this messaging plays a major role, messaging and eventing. So under AWS, it's called Queue Services, so SQS Simple Queue Service. And of course, there's a Simple Queue Service is the same, but just a differentiation on Azure, it is a bit different, where Azure has a queue storage and service bus. So that's why it is repeated. But SQS, SMS for notification requirements, and they recently introduced the Event Bridge, which is more event-driven notification requirements, where AWS Event Bridge will help with that, similar to SNS only, but an advanced SNS feature. And and here it is equivalent to that is Event Grid in Azure, where you get a lot of messages, producer, consumer, all these things will be there. And in GCP world, it's all one product, which is Cloud PubSub. Cloud PubSub is what is the solution for Kafka or the source. You can think messaging as a open source world. Kafka is more popular. So the answer to Kafka in GCP is Cloud PubSub. So yeah, and then the respective words here. So and this is about messaging and web application. Yeah, this one it is a miscellaneous category where for web application we want to have all the web application postings. We can do it, and I mean it's more coming under PaaS. And we already saw this in the first slide also in the compute, where AWS has a Elastic Beanstalk, where you can, if you have a jar file or a Python library, so you can deploy that directly into this Beanstalk. Primarily, these are all web applications that can be hosted here. That's why it's coming under here as well as there in the compute. But logically speaking, it will most fit here, because generally the web application hosting that you do will have a UI and the UI layer and the backend layer. So UI developed in some UI technologies, backend in a backend technology, you can both deploy the libraries into the managed solutions, managed servers on the compute front. So that is the answer for that is Elastic Beanstalk. A variation to Elastic Beanstalk is Lightsail, where you don't need to even manage even Beanstalk. You need to give some inputs like what is your runtime and other things. But let's say you're even not interested even to do that. The more advanced solution is Lightsail. Light from the name itself is more lighter. So Lightsail is a solution where you can deploy your blindly throw your library into this, and then it will deploy it. The equivalent answers in Azure is App Service, and in GCP it is AppID. Then comes let's say once you hosted all your web applications, and there all your web applications generally will have an APIs, right? I mean, your backend side you have a lot of APIs. Imagine for a small set of APIs it is okay to manage. You can manage the APIs, but suddenly if you are talking about a very big application and as an enterprise you manage many products, then your API management will become tricky. So meaning all this API management is not easy. I mean, there's so many APIs and logically grouping them, and also there will be status codes, how many of them, how many APIs were successful and how many APIs were failed. You want to manage all those things. And the count is huge. Then management of APIs will be tricky. So that's where this API management suite will help. The answer for that is API Gateway in AWS, API Management in Azure, and AppID. I don't know how do you pronounce this, AppID or AppID. So yeah, but I heard AppID is mostly used, but yeah, some people also pronounce AppID. So yeah, but AppID is an acquired product by Google. So this is primarily help you to manage all your APIs in one place. And then once you have the APIs, then you also need a content delivery network, wherein all the most used images are generally if you take a lot of time to load the images in web applications, right? When you hit any website, the website is having a lot of images, then it will take some time to load the images content into the website. And managing such, let's say if the images are many, and if there is a latency in delivering that should be right on the screen, that brings down many users will not be waiting for so long to load the page. So how to manage that? So the answer for that is content delivery network. So what this content delivery network solution will do is it will cache all your images. So that way your loading the data onto the page will be faster. So again, I think it's just a simple caching. So that's why this content delivery network. So they will help you. The answer for that in the respective worlds is CloudFront. In Azure it is content delivery network, and in GCP is Cloud CDN. CDN is again content delivery network. We see the cloud here again. So yeah, that's about this content delivery network. So nothing but it caches all your images so that your renderer will be faster. And coming to the, next is the load balancer for any web application. The more the load, suddenly your website is so popular and you see a lot of load, and balancing the load internally, like routing the traffic. You have a lot of internally you scaled the instances of the compute, but someone should route the data by looking at which compute instance is having lesser load. So someone should intelligently route your traffic to the lesser load system or the nearest latency or lesser latency system. So that's where the load balancers play a major role. So that's in that category. You have global accelerator in AWS, front door in Azure, and cloud armor. I think I made a mistake. It is cloud. This should not be armor, but I will double check this. It should be, yeah, it should be global load balancer here. Sorry, not cloud. Cloud armor is under security. Right. So that's where this web application plays a role here, right? I think I will probably logically break here. So here the networking is a wider area, and networking is what is it is more or less common in all the three cloud vendors, but I think the names are a bit different. But yeah, but the concepts there are some differences in GCP which I observed. Probably I will once we go deeper into this, we will see I see a lot of GCP has done a bit different in the networking area compared to AWS and Azure. That is something which I saw is not very common, but they took the different ways in networking, but conceptually they are same, but internally how that concepts are implemented are a bit different. So probably once you go to the details, you know that. But as of now, for comparison, I think whatever the isolated private network, let's say you want to create a boundary of all the computes, you want to put all the compute within a private network boundary, then answer to that is VPC, virtual network, Azure virtual network, and in GCP it is virtual private network. So and the DNS management, like the domain management. So, for example, the Google.com or AWS.com or Azure.com. So all this the domains that you are managing. So for that you need to manage. You need to tell what is your IP address and how, and you should also purchase the domain, and you should tie this domain that you purchased with your public IP of your VM. So that the translation of your domain name to respective IP is what is DNS management. So that domain management, this answer for AWS is Route 53, and in Azure it is DNS traffic manager, and here in GCP it is cloud DNS. Right? Yeah, this hybrid connectivity category. So the hybrid connectivity means primarily we're talking about on-premise and data center connecting to cloud. So basically you have resources in cloud and also you have resources in on-premise. but you should not see any difference in terms of connectivity to your on-premises cloud. So for that kind of a category where hybrid connectivity plays a major role, in that especially, let's say you want to in terms of how to route the traffic from your on-premise to cloud. So you have a lot of options. Either you can transfer the data over the internet, or it can be on private network for security reasons. So now let's see the private network category, where the data being transferred from your on-premise to cloud or cloud to on-premise is not over the internet. So that's what it's mean by private network. So for that category, so the answer in AWS is AWS Direct Connect. In Azure, it is Express Route, and in GCP, it is Cloud Interconnect. So using this product, basically, you will have, let's say, an enterprise. Let's say you have storage. Let's take storage as an example. You already have a storage on your on-premise, and also you have storage on cloud. Or let's say you have a VM in on-premise, and let's say you also have a VM in cloud. So, but you want to use both for whatever your requirement. You want to use both. So then, or let's say you're opening a new data center or in a different region, and you want to connect that new data center also to your network, and also you should talk to cloud. So all these requirements, let's say you want to route the traffic between them on a private network, not on internet, for security reasons. Then yeah, these are the tools that you can use in clouds, right? And then same hybrid connectivity category. Let's say you want this is on internet. So if you want to use route the traffic on the internet, then VPN is your solution. So for VPN, the answer is in AWS is VPN gateway. In Azure, we have two variations: VPN gateway and let's say this VPN gateway is for two site-to-site. But let's say if you're talking about multiple sites connectivity, like you have multiple sites and you are a global company and you have multiple sites to connect, and multiple office locations within a region, suddenly that will be a bit tricky, right? So in that case, you are a global company and you have multi-region and multi-site, then the answer to that is virtual WAN in Azure. But yeah, in GCP world, it is cloud VPN gateway. Again, the cloud is repeating here. So the cloud VPN gateway is the GCP solution, and this is over internet. And just opposite is this is not over internet. This is private connectivity. So here, this private connectivity and all these cloud vendors are expanding in terms of networking. But in some places where there is, if you're in a remote place and if you're looking for a cloud connectivity, good thing is that all these cloud vendors have a tie-up with their local telecom vendors, and they tie up with them and do the data transfer, or they take a lease line and then do the data transfer. It has become costly and it's time-taking process, but yeah, but still you have an option to utilize that. Right? And then dynamic route management. Probably I think it's a little bit tricky to. I mean, these are all more on networking side. Let's say you want to manage. How you manage your network traffic? Like if you want to use Border Gateway Protocol, which is BGP. I will explain all these things once we go deeper. But let's say you want to manage the traffic and you want to do a dynamic routing on networking, then the answer for that is again VPC, which is a broader layer here. And Azure, it is Virtual Network Gateway, and in GCP, it is a cloud router. So it's just like, I mean, a router from that you can understand, right? So also most of us have routers at home or at office. So yeah, what router does is more, it manages the traffic. So that is what it is. This category comes under. So then load balancers. Load balancer will come under, I mean, web application we saw here, but also they also come under networking category. Primarily they will come under networking category, but there are commonalities with web as well. But yeah, coming to load balancer, every cloud vendor has a two variation. One is the network traffic, and the other one is HTTP or HTTPS, or web traffic. So there are two variations in all the cloud vendors. The network traffic is not is a traffic which doesn't use HTTP or HTTPS. It is our primary UDP network UDP based protocol traffic. So the network load balancers they they help you. I mean, mostly we use HTTP HTTPS, but internal traffics they can all go through network load balancers, which could be more faster. That's why they're still popular, and they're most heavily used compared to this HTTPS based traffic load balancer. So this network load balancer, the answer for that is in AWS it is network load balancer, Azure it is load balancer, and in GCP it is network load balancing IND. So if you're looking for HTTP or HTTPS web traffic, and also looking for a globally managed, let's say it's a global load balancer. Globally managed meaning across regions. You're talking about traffic moving across regions. Let's say if one resource of one region is down, and your traffic has to be migrated to a different region altogether, then your load balancer should be it should not be internal, it should be external, meaning it should be outside your network. So that's where global load balancers or web traffic based load balancers will come into picture. So in that category, so we have application load balancer. Here we have three components here, which we saw when we were also doing Azure. Application gateway, front door, traffic manager. All these three come under the web and global traffic management category. And here it's all one global load balancing. So from what I see is that I mean, in most of the places Azure has many products under networking, meaning more than one for a given use case, but they have a minor differences between. Let's say in load balancer category, Azure has 4, whereas AWS and GCP has only 2. So, but they have their own use cases, but they are all managed as different products, but the use cases are a bit different. But they all come under load balancing, but the use cases are a bit different. Yeah, so that's about networking. Probably I will take a break here. That's already we also have time. But if anything else you want to discuss, so maybe we'll discuss that. Before that, any questions here in this?
That's a good comparison, Sham. Actually, like of every cloud vendor, like it's very good, concise way of kind of just looking across all the cloud vendors and saying that this is very good.
I think
so. Janish, you can sell it, man. Take this and cloud seller, okay?
Yeah, we'll go and do the sales engineering. We'll say, okay, agile rules.
Cloud only, cloud.
We can be agile across clouds.
Yeah.
But I think this actually gave a good perspective. In sense, I mean, preparing this, I mean, I had to refer multiple sites to get this comparison. But I know AWS and Azure, but GCP I'm learning. But yeah, I want to first, before getting into the deeper into specifics, I want to get the breadth, like where and all GCP is there, and how is that in comparison with the AWS Azure, because I know these two better than what GCP, I mean, compared to GCP knowledge that I have. But I think this gave me an idea that GCP is almost already covered in all the places what other vendors are there. So I mean, I had a different view of GCP, but now I'm revisiting my knowledge. So I think
the four pillars, I think all these guys are almost equal. No, there is not much of a difference. Exactly. It's only the other products on top of it. That's the kind of other people are leading. But I don't think it will be for a long time. Probably another 1 year, everybody will be almost in the same way. So they have to keep adding to it. The competition is going to make it more of innovation, I think.
Yeah, you snatch somebody from AWS and just bring out the 4 pillars. Yes. If you want a house next door, you bring the same architect over here.
Yeah.
That's sooner or later you will have that. Yeah, right.
Yeah, you can even take the shuttle from that guy, right? This SpaceX